in the previous class, in the previous video, we had seen the how to calculate the gradient descent, and I have mentioned that I'll be explaining about the derivatives, how we perform the derivatives in this. In the gradient descent, we had seen that the change in the weights and also the change in the error rate. Okay, so to know the derivatives, so we'll take some simple examples. Let's take that the x and y as, so this is consider let me say take this the value a, and this is nothing but the output f of a. So for the input a, the output f of a, or a function f of a is, so is what is the f of a, that is what we'll have to calculate. Okay, so for that we'll have to, let's draw a linear line where we can say that if my input is 2, okay, then my output, if it is 6, then it means that a is equal to 2 and f of a is nothing but 3a. So when it is 3a, then it means that 3 into 2, which is nothing but equal to 6. So when I plot the same thing, you get it in this way. Now, if I increase my a to 2.001, okay, if I increase my a by 0.001, okay, then my f of a will be 3 into 2.001, which is nothing but 6.003. Okay, so what you can see is that I have changed my weight to 2.001, that is, there is a difference of 0.001, and my weight has been increased by 0.003. Okay, so this is what you can see. Now when I see this difference, you can see that this difference is 0.003 and this difference is around 0.001. Okay, so if I nudge so as a result, if I nudge the 0.001 to the right, that is from 2 to 2.001, then my f of a went up to 0.003. So the slope of the function, so slope of the function of derivative of f of a at a is equal to 2, okay, is 3. That is, the slope is nothing but 3. Why? Because at a is equal to 2, f of a was equal to 6, and at a is equal to 0.001, f of a is nothing but equal to 6.003. So you can see that if my a is equal to 2, okay, f of a is equal to 6. Similarly, if my a is equal to 0.000001, okay, then f of a will also be equal to 6.000003. Okay, so you can see that at any value of what we are trying to change it, okay, so our slope will be 3 times this value. So you can say whatever the value is this, the slope is nothing but the 3 times this particular value. Okay, therefore we can say that slope at a is equal to 2 is 3. So we can say that d of f of a dA, okay, that is when we nudge the value of when we nudge the variable by time amount, okay, so slope of the function f of a is nothing but equal to 3, that is d by dA of f of a is nothing but equal to 3, okay. So when we nudge the variable time out, that is even if it is like a is equal to 2 to a is equal to 2.001 also, okay, we get the slope of the function is, okay, 3. So this is about the one example of derivation. Now we can take another any other example where we can say that, let's say for example, okay, our a value is 2, okay, and we change the, if I change the value as 2.001, okay, so let's say that if f of a is equal to 2 and f of a is nothing but 2 square is nothing but 4, so you can say that this 4, if I change the value as a is equal to 2.001, then f of a is equal to 2.001 whole square, which is nothing but 4.004001, which is nothing but 4.004 is what we get it, okay. So we can say that 2.001 is nothing but we get it as 4.004. As a result, we can say that, okay, the slope here is, okay, this 0.001 and this 0.004, if we compare it, is nothing but equal to 4. So slope is nothing but equal to 4 because it is 4 times. You just see the after decimal points here. So it is 4 times. So that is nothing but slope is nothing but equal to 4. Therefore, d by dA of f of a is nothing but equal to 4 when a is equal to 2. Now, if my a is equal to 5, then f of a is nothing but equal to 5 square, which is nothing but 25. If my a is equal to 5.001, then f of a is nothing but 5.001 whole square, which is nothing but 25.010. Therefore, my slope now has become equal to 10. So when my a is equal to 5, my slope will be equal to 10 for this function. Okay, so we can take any example and we can just find out, okay, the derivative. So this video is to make you understand the the, the derivative part. Okay, how the change in the weights or change in the function. Okay, what value will be getting for that. Okay, this video is with. I hope this is understood. If there is any queries, we will see in the next class. Thank you.